conventional energy. That simply means the energy that most people in the world at this time are using. So this is all non-renewable energy. Most people aren't using just renewable energy, largely because we're still developing technology to make that accessible and cheaper and etc., yada, yada, yada. So this case study is an example of a document-based question that you could get for the AP test. So of the free response questions you get, at least one of them, I think it's only one of them, will be a document-based question. So you'll be given a piece of text that could be this long, it could be maybe only a couple of paragraphs long, but then you'll be asked questions that relate to whatever that document is. So the nice thing about the document-based question is that a lot of the time, maybe half of your points can come straight from the information you're given. The rest of it you have to supplement with your own information, but if you're looking at these, A, you can get the answers from the reading, and at least one of the points from B you can get from just reading the text. So that's the nice part about a document-based question. And we'll talk more about coal as we look at 19.2. So 19.1, this is the first page of the chapter that actually has meaty content on it. It's page 428. What you need to know is just a brief history of how energy has been used, kind of overall. That's just to give you some background information for looking at how society's changed or how society might change. So you want to know that we first started off using things like animals, so actual literal horsepower, cattle, things like that to do work. We used things like firewood, that would be biomass. And we've been using wind and water technology for a long time, just not on a very big scale. So windmills we've used for quite a long time. Water wheels, those have been around for a long time to do things like grind grain for bread to make flour. Okay. Around the time of the Industrial Revolution, that's when coal really took off and started to be mined and used heavily. You probably were familiar with that already. Do you know why coal became heavily used in the Industrial Revolution? What else was designed at the same time? Yeah, the steam engine. Yeah, the steam engine, the steam turbine. So because that is something that required a fire, it made sense to mine coal in order to power that. Okay, so we'll talk more about how that works. And then oil took off in the 20th century. So we've been mining oil for the last several decades, 100 years, something like that. I can do math, I promise, as long as I'm not talking and I'm recording myself. Some other things that you would want to know off of this page are examples of geopolitical or economic problems from using fossil fuels. So there are some things that are listed specifically as examples here, but every section also talks about additional problems. So you don't have to memorize all of them. You should be able to give a couple of examples of economic problems and then geopolitical problems for each type of fuel. Okay, so that would be coal, oil, natural gas, etc. This is an interesting fact that could be helpful for a document-based question or a free response question. We should, according to a lot of environmental scientists, leave 80% of what's left of our fossil fuels in the ground. So there's a lot of resources left we could burn for several thousand more years. But if we do, then the risk of climate change is pretty great. So we're supposed to leave 80% of what's left so that we limit climate change to less than 2 degrees Celsius. Right now we're at, I think, about 1 degree Celsius of change. Okay. This table 19.1, talks about measuring energy. You don't need to know all of them, but you should know what a joule is. So a joule is a way to measure current over time. That's amps per second. You should know what watts are. A watt is a way to measure the power. So how much energy is used. So that's joules per second. You need to know what a kilowatt hour is, which if you understand the metric system, kilo is 1,000. So a kilowatt hour is 1,000 watts per hour. Okay, so lots of per time things. If I'm going too fast, please let me know. Okay. And BTU, you should just know what that stands for and have a basic understanding of that. So it's British thermal units. And that's how much it takes to heat 1 pound of water by 1 degree Fahrenheit. That's an interesting one. But that's kind of like the definition of, I think, specific heat. So it's, again, how much it takes to heat 1 pound of water by 1 degree Fahrenheit. Okay. You should be able to define energy and power. So energy is just the ability to do work. If you don't have energy, you don't have the ability to do any work. Sometimes that's how it is in the morning. Power is how quickly the energy flows or how quickly the work is done. So that's why watts is a way to measure power, because it's over time. So how long it takes, or how quickly you can do it. Okay. This PP on this sticky note, it stands for power plant. So in general, a typical power plant produces much more energy, about 1,000 megawatts, than a wind turbine or a solar plant. That's part of the problem with developing renewable energy resources, is that it's not as efficient, or it takes up more space, or you need more of the machines. A larger power plant can produce 2,000 or more megawatts. You don't have to know the exact numbers on these, but just in general, you should know the difference between how much they require. So again, for a typical power plant, you need to have the same number of wind turbines. You're looking at having hundreds of wind turbines to get the same amount of power. And for a solar plant, you need a couple of those to get the same amount of power as a typical power plant. Okay. Good. All right. Moving on. We love graphs. Graphs are wonderful, except I think this one's a little bit confusing. So this first one in the upper left corner talks about fossil fuel usage. So we most use oil, and then natural gas and coal. So you kind of need to know oil is used the most, then natural gas, followed by coal. Richer countries in general use more energy, but countries like China and India that have emerging economies, they're catching up in how much energy they use per person. So you might be asked to rank countries in their order of energy usage. If you know in general the richer countries tend to use more, and then countries like China and India are probably next, and then other poor countries would be following that. It should be easy to answer a question like that. This chart, for all of its data, what you really need to know from that is just in general where energy in the U.S. is used, so what kind of industry or things it's used for. So in the U.S., we primarily use most of our energy for transportation. Most of that energy is used for motor vehicles. So it's the individual person driving back and forth to work or back and forth to school. Then next, industry uses a lot of energy. So in order to mine for different types of metals and different products, in order to forge things, the chemical industry uses a lot of energy to produce the different chemicals that they sell. And then that's followed by residential and then commercial. So residential use, that's you in your home. Commercial use would be, I think technically the school would count as that. The state farm agency in town would count as a commercial business.
I was like separate dates, such as some like cargo ships usually use about the most amounts of energy.
So cargo ships, like shipping cargo on boats, that can take a lot of energy. From my understanding is that things like trains and ships and pipelines are actually more efficient than driving them individually or flying them. So even though most of the freight traffic in the U.S. is carried through trains and ships and barges, it's pretty efficient, so it doesn't use most of the energy in the U.S. Okay. Moving on. Okay. This might seem like a no-brainer, but producing energy does consume energy. So making electricity at power plants for us to use takes energy. We lose energy when we do that. So burning coal to get electricity, that's my example. We actually lose 2/3 of the energy in the coal when we do that. It's not a very efficient process. Okay. Bless you. Bless you. So you should be able to answer questions like the section review number 2. What are the major sources of commercial energy worldwide and in the U.S.? And question 3, how does energy use in the U.S. compare with that in other countries? Okay. Bless you. Gesundheit. Salud. That's all I got. Okay. 19.2 talks about coal. Okay. Coal is one of the non-renewable energy types. So what is coal? It's fossilized plant matter. Okay. In order for it to be produced, it does take a long time. That's why it's considered non-renewable. Something like firewood would be renewable because we can plant more trees and harvest those within somebody's lifetime. But coal is non-renewable because it takes thousands of years and a lot of pressure and heat to form its structure. Okay. I mentioned before that there's a lot of coal and other fossil fuels available, but we don't want to use all of them. So back on this page it says that there's more coal than we can use. And that's true. We can't actually get to all of it, at least at this point, but we don't want to burn all of it anyway. Okay. From this figure up here, this is the kind of in general stuff that you should maybe not know the exact numbers for, but have an idea of which country or area is first. So these are the places that are proven in place or proven to have coal. So we know that the place that has the most coal is Europe and Eurasia, followed by then North America, then followed by South and Central America. So coal is primarily in Europe and then North America. That's where 60% of all the coal is. Do you know what mountaintop removal is? Mountaintop removal. There's an explanation of that on this page, but essentially it's where mines come in to an area, generally at the top of a hill or a mountain. That's why it's called mountaintop removal. And they literally blow off or take off the top of the mountain to get down to the coal. So they're not digging into the ground so much as they are just removing what's covering the coal. And then when they put it back, they don't necessarily do a good job of fixing it back the way that it was. So you have erosion that occurs, all the sediment and stuff that was trapped in the ground there is able just to leach out. So that can be problematic. And the people who live near sites where mountaintop removal has occurred will often talk about how their quality of life has changed. And it's not in a good way. It's gotten worse since those operations happened nearby. This figure down here briefly explains how a coal-fired power plant works, so how we get electricity from that. It's not that the coal directly gives us electricity. There's actually a couple things that have to happen in order to generate that electricity. So you should in general be able to explain the process. You'd never have to draw it out. But the numbers here of the 1, 2, 3, that would be a good way to summarize what happens. Okay, so the coal gets burned in a combustion chamber, and that combustion chamber heats water, which turns to steam. The steam turns turbines, and then the turbines generate electricity. In order to cool off all of that water, though, there's a cooling tower that the water is piped to. Okay, that's pretty much it in general. Can I keep going? Okay. All right. You should be able to talk about the pros and cons of coal. So some of the good things, we've been using it for a long time, so we know how to do it. We already have infrastructure built, we have power plants built for it, so we don't have to spend money in order to make more power plants to burn coal. The pros and cons do start on the previous page as well, so you can see pros and cons on both pages.
I take pictures of your note cards afterwards.
Say that again?
I take pictures of the note cards afterwards.
Yeah, you can take pictures of what I've got. Or I'm supposed to be posting this online, so we'll see if that works too. I've got to figure out how to get it loaded, but I'll probably create a page on our class page that will be all the videos. So you can listen to me over and over and over again. It's totally what you want to do on your free time, I know. Some of the cons of coal, though, is that it is a dirty process. So burning coal produces a lot of byproduct, and there are health problems. Things like radioactivity. Coal plants emit radioactivity from uranium and thorium. That's not something a lot of people know about. And that can potentially be a problem. Okay. So then this section on this page talks about why coal use is declining or why it's being limited. You should be able to explain that. Why is that happening? So in part, it's because we have made improvements in other technology, so we're able to use some other renewable energy resources. But also, the power plants are getting old. So there have been several laws passed and regulations passed where plants are supposed to limit how much toxins they put into the air. And some of the power plants got around that in, I think, the 70s or the 80s, because they said, well, we're going to close soon, we're going to shut down soon, but they're still running. So there have been some laws passed more recently that are causing the coal companies to either have to build completely new power plants or revamp the ones that they have, so that they do meet those standards and those regulations. So the companies are looking for other places, other countries where maybe they'll burn coal, so we can ship our coal there and we can burn it there and produce electricity there. But from the other page, coal requires a lot of water if you're going to produce electricity from it, because you have to have water to produce the steam, and then you have to have enough water to keep burning and producing electricity with the steam while the water that you've just turned into steam is also cooling off, because it can't all be used at the same time. So it takes a lot of water. So places like China that could maybe use the energy aren't able to burn a lot of coal because a lot of places in China are arid, they're dry. Okay. So how many of you maybe remember hearing about a carbon capture or cap and trade program? You might be too young. Yeah, it's in the book. You might be too young to remember it. I remember it, but I also remember it probably better than most other people my age because my dad works at a refinery, so he's just in the computer side of things, but I heard more about the debate because he was involved. It could have affected his job. So carbon capture is the idea that the CO2 produced by coal refineries would have to be captured. So you have to build special equipment to make sure that it's not just released into the air, and then it would be pumped deep underground. And if a plant can't do that, or if they don't want to do that, then part of the program could involve them buying the ability to release more carbon dioxide from a plant that's doing a better job. So plants would get a certain amount or a certain limit of, you can produce this much. If you don't produce that much, you can maybe sell part of what you're able to produce to somebody else so they can produce more. Does that make sense? It's kind of a roundabout way to do things, but that was one bill or a couple of bills that have been thought about. So the pros for that is that it does limit how much carbon is produced, but the con is it is expensive. It's very difficult to take an existing plant and convert it to be able to do that well. Yeah. Okay. Oil. Oil is also petroleum. So they're pretty much interchangeable terms. So oil is also plant-based, but generally it comes from marine algae or plankton. So because its origin tends to be from the oceans or a body of water, then it's deposited in a different type of area. So its deposits are usually in sand and shale. So it can be really messy and difficult to mine for oil or for petroleum.
Call it oil.
Good question. I don't know. I don't know the origin of the word. I don't know the origin of the word petroleum either, though. I just know that that's what we call it. I know that if you look at oil that's raw oil or crude oil, it looks like what you would think an oil looks like. So vegetable oil, cooking oil, they kind of have I guess the same look and the same viscosity, so it doesn't flow very well either. Peak oil date. It's a vocabulary term. It's in bold. The peak oil date is something that was predicted by a scientist, Hubbard, who said that, okay, by this day, this is when we're gonna be harvesting and getting as much oil as we can. And after that, we're just gonna have less and less oil available. That date's changed. This person predicted in the 1970s, or in the 1940s, sorry, that the peak oil date would be the 1970s. And that date is later than the 1970s now because we've discovered that there's more oil available. We also have new technology that makes oil that was previously unusable able to be harvested and then used.
Case
So, what?
Case damage.
Sure. Sorry, I was like, you're asking about this. No, you're not asking about this. Yeah, go ahead. Go ahead. Okay. An example of some of the things that are now available are tar sands. Canada has a huge preserve and reserve of oil because of the tar sands and how much oil is in the tar sands. So, kind of an interesting thing. In Detroit, the Marathon Refinery in Detroit specifically built equipment to be able to process the tar sands. So one of the byproducts of that is the stuff that goes into asphalt. So other than the stuff that they release into the air as air pollution, they don't actually have any byproduct that they have to get rid of or ship or store anywhere because it's all used in other products. So they get to sell the stuff that goes into the asphalt to road companies, and that gets used. But it still is a dirty processing. So this figure is like the other one that we looked at, but this one's specific to oil. So you want to know kind of the top countries or top areas. So if you're looking at countries individually, Venezuela actually has the most oil. But if you look at general areas, we would still say that the Middle East is the largest area of oil reserves. That number is declining though, largely because there's a lot of mining for oil being done in the Middle East. So as we exhaust those reserves, they have less and less of the proven reserves. Okay. You're probably more familiar with the BP oil spill. And this is a con of mining for oil. It was an oil spill that happened deep underwater, and then it took them 4 months to plug the leak. So unfortunately, that's one of the best places to be mining for oil is in deep ocean areas. So it's also dangerous for the workers, but companies are still doing it. People still sign on because it makes really good money. The Arctic Sea probably has the largest reserves of oil and known gas. I have a question mark because we're not 100% positive on that, but it probably has the biggest reserves of oil and gas. And that's a fact that you could read in here, but you could also just write it down and then you'd be good.